Welcome here, everyone.
Morning, how are you?
Good morning.
Welcome, everybody. We're going to talk today about the Zero-ETL approach and enhancing data agility and insights. Zero-ETL is all about getting access to data immediately in real time. And so we're going to talk about the number of ways that we do that in FME.
All right, great. So to get us started here today, we will introduce our presenting team. So I will hand things over to Chris to introduce himself.
Hey, my name is Chris. I'm part of our customer solutions team here at Safe Software, and I do quite a bit of webinars and talk to a lot of different customers and help them get up and running with new use cases in different departments of their organization. Stuart, do you want to go next?
Thanks. Yeah, my name is Stuart Harper. I'm VP of Product Development at Safe. So I work closely with Don and with others, helping kind of define the product roadmap and also overseeing engineering and that side of the business.
Fantastic. And Don.
My name's Don Murray, and I'm the co-founder of Safe Software, and I'm happy to be taking part in this topic today.
All right, so at this point, I've gotten our presenters to turn off their webcams to save on some bandwidth. And just a quick intro to Livestorm in case you are newer to the platform. If you have any audio issues throughout, you can click that help button on the bottom left for 4 simple steps. Share your emoji reactions with us during the webinar. We love to see those. And then if you have any questions throughout the webinar at all, please do drop those in the questions panel because we will have a Q&A session at the end. And we'll keep an eye on that throughout the webinar as well. And keep letting us know where you are tuning in from in the chat. All right, and I'll hand things back over to Don to go through our agenda.
Okay, so thank you, Elizabeth. So here's the agenda. First of all, I'm going to give a high level, set the stage. What is ETL and reverse ETL, just so we're all have a common understanding of what those are. Then spatial data and ETL. Then what is Zero-ETL. And then Stuart and Christian are going to take us through the next few sections: real-time data services, connecting applications in real time, and high-velocity data streams, and give us a demo for each of those. So that's really going to be really drive home and show how we deliver each of those. Then I'm going to talk about data virtualization, and then we'll do some conclusions. So there we go. So let's take it away here. Okay, first of all, at the very highest level, what do we mean by enterprise integration? Well, for us, enterprise integration is when you're integrating all the applications and data stores across your whole organization so they operate together in unison. It's about getting the data from where it is to where it's most needed to get value and when it's needed. Extract, transform, and load, or ETL, is one way to describe the technology to do this. So, okay, what is ETL and reverse ETL? In both cases, you have systems and you have data stores. We support hundreds of both, but for this, I've just taken some representative systems. And ETL is simply the idea of being able to read data from multiple systems, combine them together, clean them, resolve differences, improve data consistency, and load it into data stores. So extract from the systems, transform it to get it in the form that you want in your destination system or systems, and then load it into those systems. And when we built FME, everything is many-to-many, but of course, it could be one-to-one or it could be many-to-one, whatever you want. But the point is, extract is transform and load. Traditionally means taking it from systems, combining it, and then putting it into a data store. And why would people do that? Well, it's critical for businesses to combine data from multiple sources to get a unified view, to see the whole business or get a whole view of the customer for reporting and analysis. Pulling data from many systems to combine it, you get a more holistic view. That's what ETL is about. What about reverse ETL? Reverse ETL goes the other way, taking data from one or more data stores, transforming it, and loading it into systems. And so when you load it into systems, you might have resolved things like customer addresses. You might have cleaned up some other data to make it more consistent. So when you push it back into your systems, it's cleaner. And why would you do that? The systems is where your data actionable workflows, your tools, and things that support customers, manage operations, and drive business growth. The data empowers that, but it's actually the systems that do those workflows. And so if you can get better data into those systems, you're going to drive business growth better. You're going to make better decisions. To us, any type of ETL is all about getting and combining data from wherever it is. Could be, whether all on-prem or different systems, or, spread across multiple different clouds or systems in the clouds or wherever it is, combining it to get it to where you need it, when you need it, and how you need it, i.e. the schemas that you want the data to be in so you can drive better business decisions. This data movement is what our platform is all about. So what about spatial data and ETL? Well, the world we live in is spatial. Think about how many ways you personally use spatial today without even thinking about it. You just, you wake up, you go get your coffee, you have breakfast, you made it to your computer screen today, whether that's in your home office or whether that's in your office downtown or wherever your business office, your company office is. Maybe you took your dog for a walk. Everything you do is spatial. Everybody is someplace all the time. Everything is someplace all the time. Every event occurs someplace. Yet, surprisingly, most businesses do not use spatial data to gain insights. And so I was recently at a Gartner conference, and they talk about digital optimization and digital transformation and how spatial data is critical to move from digital optimization to digital transformation. Without spatial data, you can optimize your data till the cows come home. You can make it more consistent, make it cleaner, all these things. You can optimize, but you're not going to get the new relationships and insights that spatial data delivers to deliver even better decisions. You're just not going to see how your customers relate to your mobile service force, how your customers relate to where you want to build a new store, things like that. You just cannot see it without spatial data. So you're going to miss those opportunities. You're going to allocate resources poorly. And if your competitors are using spatial data, you are going to fall behind. There's no question about that. And we're seeing more and more companies starting to use spatial data because spatial data is critical for all types of ETL and data movement. And whereas we see spatial data everywhere, it can be in Excel spreadsheets, can be in plain databases, can be in spatial databases, can be in Gen AI. You can use Gen AI to enhance it, generate it. AR, VR is spatial. Spatial data is absolutely everywhere. And when you look at how FME supports spatial data versus all the other enterprise integration tools, it's not even close. They don't take it seriously. You ask them what they do. Many of them just say, we don't do that. FME is the only enterprise integration tool that fully supports spatial data types and all data types. So what is Zero-ETL? Again, we have the same systems, but what Zero-ETL is connecting these systems together in real time. So if something happens in one system, other systems are always updated. If you have a real-time data, high velocity data stream, incorporating that so you get the data from that into your systems. Being able to deliver data to your people using data, get the most recent kind. So Zero-ETL, giving everybody direct access to the current data and services. Real-time data synchronization across your systems, flexibility and agility, so data flows across all systems and data stores in real time. That's what Zero-ETL is about, and we're next going to show some demos on that. So Zero-ETL delivers real-time data management so your organizations can respond quickly to the needs and opportunities that appear using the latest data always. How do we do that? Well, here's our enterprise integration platform. FME Form is where you build the data movement and transformations, i.e. the workflows. And then FME Flow is where you bring life to those workflows so that now things happen in real time immediately. And FME Flow Hosted is our SaaS version of that. So if you don't want to stand up your own, you just want to use FME Flow in the cloud, then FME Flow Hosted is FME Flow, but we look after the deployment for you. So FME Flow delivers Zero-ETL. Without FME Flow, you cannot do Zero-ETL. And now I'm going to hand it off to Christian and Stuart, who are going to walk us through the different ways that we deliver Zero-ETL to the enterprise.
Awesome. All right, let's get started with talking about real-time data services and the last data mile. So we're going to start off by talking a little bit more about the features and functionality available on FME Flow. And the first thing that is notable here is that we have unlimited managed users with FME Flow environment. So that means you are not limited by the number of users that are able to access your FME Flow instance, run FME Flow workspace apps, or anything like that. You're actually licensed per engine. So engines are actually also very flexible with how you want to deploy them. They can be deployed basically wherever you need them to be. We like to kind of say get the engine as close to the data as possible, and that will help to cut down any latency and improve performance as well as security. To support all of that as well, we do have things like advanced engine management. So if you have some business critical jobs that need to run and you need to dedicate certain engines or queues to those jobs, you can run them in that manner as well. And that is just an additional functionality that's available in the product to help ensure that your jobs are being routed to the most efficient and most optimal engine as possible. So that helps with ensuring delivery as well as making sure that an engine is always available if a business operation depends on that. So we'll start off by talking about a couple of different use cases here. And the first one we're going to go through is data streaming workspace apps. And this is going to be an example where a user is going to upload a file and it's going to be streamed. The results of that workspace are going to be streamed back to them in real time. This is going to be for data standards verification and data validation. So in this case, we're going to have a CAD file be uploaded to FME Flow. The workspace will then scrutinize the geometry, the attributes associated with that. You could go so far as to the metadata or even like the line color, the line weights, depending on what your validation needs to be, how strict or lenient it needs to be essentially. You can choose how strict you want that to be in the workspace that you publish before making this available to the general public or your internal users. So it's a very easy web app for people to use. Essentially, they need to access a URL. If this is a publicly accessible FME Flow instance, anyone can access it. You can have it authenticated, or it can be, again, open to the general public. And in this case, it's just a generally available one. So what's going to happen is, we'll go through the example in a second. I'll just give you the diagrams here. The user is going to upload a file that's going to be executed on an FME Flow workspace app on the next available engine. Again, your FME Flow instance can have multiple engines. So in this case, it's structured to just pick the next available engine. Could be from any region that the engine is deployed in, or if they're all deployed on premise, it'll just wait for the next engine to be available before executing that job. The result of that will be either the CAD validation passes and it gets submitted into our staging environment, or it fails and the results go back directly to the user with the form of a validation report where they can look at the features that failed, look at the geometries that failed, get the reason for the failures, go back and make the edits before republishing this data set. The alternative to this would be, again, if this is a business critical operation and you need to run it on a schedule, or not a schedule, if you need to run this and ensure it's always available to a specific set of engines, you can dedicate a number of engines to a job queue to ensure that this is always run as fast as possible. So again, there's just a couple of mechanisms that you have available in the FME Flow environment to help ensure this is delivered as efficiently as possible. Some sample reports that you're going to look at here are on the left-hand side, a passed validation. So that would indicate that all of the features, both the geometry, the attributes, and everything else that you're validating in that workspace have passed and have gone into the staging environment. So this expedites the need for anyone on the GIS or CAD teams to review any data sets that are submitted by the general public, whether those are contractors or developers, and allows it to go directly into their staging environment if that's where they want the data to go. The one on the right-hand side, more in the middle of the screen, is a failed validation. So in this case, the validation has actually failed. We have to give the customer a lot of reasons for those failures. So again, they can go back, look at the features that failed. They have the feature IDs, because again, you're working with an FME workspace in this case. So you get all the information all the way down to the individual entity IDs, allowing the person who submitted to go back, make those edits, and then again, update that before resubmitting. So let's run this live. We'll take a look at how this ends up looking. So again, you just access the FME Flow workspace app from a web browser, and it is a very simple drag and drop interface where the user simply just needs to bring in their CAD file and click the run button. From there, they don't need to be an FME user. All that's happening behind the scenes is an FME workspace is running, and this is going to give them real-time feedback as to the status of that file that they've uploaded. So again, in this case, we're looking at a failed validation. We can click on a feature on the map and see that there was an invalid feature due to the diameter attribute not being valid. We're working with water pipes in this case. The diameter has to be greater than 0 because water would not flow through it otherwise. And so now we'll take a look at what a good validation will look like. Obviously, this was a little bit staged, so we can see a failed and a passed report. But in this case, we're getting the good file going up to the FME Flow workspace app. We can see that the load was completed and the data validation was successful. Click on some features to get those feature IDs just for verification. And I can go into ArcGIS Online, which is the staging environment in this case, to see that the dataset was updated. I'll just refresh the page. And we can see the timestamp in the top right. You might not have caught that, but the timestamp was just updated from 1:19 p.m. to 1:23. And yes, this was a recording, so that's why the time is a little bit off. And you can also represent these on the map as well. So anything that you can do in your ArcGIS Online staging environment would be kind of status quo here. You can kind of keep up with your regular processes, and it just helps with the overall workflow. In terms of actually configuring the workspace apps, they are very straightforward. So you simply log into the FME Flow environment, you point it to the published workspace, you set the service, in this case, the data streaming service, so the HTML is returned right back to the client in the browser. And then if you want to, you can customize it so you can see your own branding at the top. In this case, I've used the FME logo and Safe Software logo. If this is your organization, you can upload your own logo so it looks like it was custom built for your organization. And it's very easy to do. Again, all no code. Simply log into the web interface, point you to that workspace, and then do the customizations if needed. So that would be an example of a user or a developer who is uploading a file where you're receiving files from the general public or contractors, developers, doesn't matter who. What about an example of downloading data sets? So anytime you need data to be readily available to your field workers or anyone working on projects in the field, essentially. So we'll take a very similar approach to this, where we're going to look at a basic diagram where instead of a user uploading a file, they're actually going to use a map to select an area of interest. In this case, it'll be looking for transit assets. So we'll look at bus stops, bus routes, as well as SkyTrain stops and SkyTrain lines, I believe. And so essentially, we're going to see that same layout with the workspace apps, where the user can fill out a basic form. In this case, we'll see a map pops up. We can select the layers of interest and the output coordinate system. FME will then submit that job to a job queue. In this case, again, you could run it on multiple engines if you'd prefer, or direct it to a specific engine. And then the results of that will be delivered to the customer as a downloadable zip file in their browser. So we'll take a look at how that operates here. I might actually have to start this one manually. There we go. Okay, so very similar. We're looking at a workspace app where, again, I can use those published parameters to select what features of interest I want to download. So essentially, those would be the tables that I'm downloading. I can draw an area or a bounding box around the features of interest for my data set, select the output coordinate system, and as well, I can select the output format, because FME supports a number of different formats. If you're not aware, it's north of 450 at this point. In this case, we're working with flat files. So of course, it's going to be narrowed down to a shorter list than that. Just to take a look at the downloadable zip file to make sure everything is valid here, we've opened it up in FME form. You can open this up in any application that supports the formats you downloaded, and we'll see that there's those two files here, and the results have come back with the bus lines and bus stops. So it'll be a real-time example of getting data from a database or something, some staging environment or production environment where the customer or your field workers need access to the data in real time. And it's a very easy and intuitive way for them to essentially just draw a rectangle, draw a polygon feature, or click a dot around a buffered area that they would like to download the assets for. Okay. So I don't think it's advancing there. There we go. Sorry about that little delay there. So we're looking at going back to the CAD validation standards where the user or the developer was uploading a file. That is an exact example of what the city of Henderson was doing. So they provide their citizens with self-serve CAD upload data validation and integration into their GIS. And this has helped to reduce their data integration time by 75%. So again, you're kind of eliminating the need for a manual process to review every file that's coming in. This allows you to meet your deadlines more almost at a guaranteed fashion, because FME is going to run as soon as the data is submitted, or again, as soon as that engine is available. Keeps you on schedule, allows you to meet all of your deadlines, and will eventually reduce cost and eliminate errors as well, because this is more of an expedited process that is automated to look for any invalid submissions. So again, it allows people to help themselves when they're uploading their data sets and cuts down on overhead time for your individual teams. So we'll talk next about connecting applications in real time. This is a slightly different mechanism for running jobs on FME Flow. In this case, we're going to be looking at automations using the FME Flow web UI. So FME flow automations allow you to connect different systems so that actions in one system can update another. So in this case, what we're working with is, we'll take a look at, I believe it's a Survey 123 or field maps webhook is going to be essentially using a webhook from those systems. So as soon as a form is submitted on Survey 123 or field maps, that is going to trigger an automation to execute a number of processes. So in the previous examples, we were looking at a case where a user was uploading their files or downloading files from FME Flow and directly on the FME Flow web interface. In this case, we're looking at separate applications using webhooks or another mechanism to trigger an automation. The difference with workspace apps and automations is that a workspace app will essentially execute a single workspace, whereas an automation will allow you to chain multiple workspaces together. So we have a couple of notes here for things like parallelism, split merge blocks, and essentially all that means is that you have the ability to string together multiple jobs either in sequence or in parallel, allow them to execute as soon as that webhook is received. There's a number of different triggers that we'll look at in just a moment here. But that'll allow you to build a much more robust automation that executes multiple workspaces instead of one. You can have multiple triggers for this, so it doesn't have to be that workspace app. You can use a workspace app to trigger the automation. You can use, it's called an automation app in this case, actually. So it's slightly different, but essentially the same thing. You can trigger it with webhooks, a simple schedule, or even have manual triggers as well. So there's a lot of different options there. So automations have the ability to, very similar to any other workspace, run in a unidirectional or a bidirectional or multi-directional manner. So this allows you to have your specific integration pattern for whatever use case you have here. So if you simply need to replicate data from system A into system B, you can allow the workspace to run just to pull data from one system and push it into another. If you need them to update synchronously, essentially, whether that's one system or multiple systems, you can have, or two systems or multiple systems rather, you can have the job write the results back to the original data sets. So this would be the ETL and reverse ETL process essentially baked into one. You could do that in a single workspace. You could split it off into multiple workspaces. However you want to configure that workspace or those workspaces for the automation is totally dependent on your operations preferences there. The triggers and notifications that are available on FME Flow automations include the following here. So I'm not going to touch into all of them, but generally speaking, the more popular ones are things like the webhooks, anything coming from the Amazon systems, a file being received, whether that's on a local directory or an FTP site. All of these things can be used to trigger an automation. And there's also a portion of FME Flow automations called notifications as well, and that allows you to do something after the automation has run, essentially. So kind of completing the process here, you can run a series of workspaces, send out an email, and then continue processing additional jobs if needed, or you could kind of end the automation with a notification just by sending yourself an email saying, hey, completed, or maybe this has failed, someone has to look into it. So take a look at a couple more diagrams for another example here. So the first one that we'll look at is, again, just using more of that unidirectional where we're going from Survey 123. In this case, we'll submit a survey. FME Flow will receive a webhook from that system, and then we'll integrate the data set between ArcGIS Online, essentially where Survey 123 is writing to in the backend, and CityWorks. So this would be a great way for field workers to essentially submit, if you're doing like a tree inspection, you're going along each tree, taking a picture, ensuring it is it's safe and it's not going to fall down on the street, crush any cars or anything like that. You can go through and quickly submit all those, and FME can keep up with taking care of the integration between ArcGIS Online and CityWorks, where any work orders would essentially have to be processed. We can look at a similar example here, where if you need to update based on an action on either end, where ArcGIS Online could be updated or CityWorks could be updated, that'll essentially allow, again, those webhooks to trigger an FME Flow automation on either side. So that would be a real-time update where if an action is performed in ArcGIS Online to, say, update a feature, that will trigger the automation to run, ultimately updating the CityWorks asset, and vice versa. If you had someone who's updating in CityWorks, that would, again, get reflected in ArcGIS Online in real time. That's all, again, using the power of webhooks. So let's throw a third system into the mix here just for the sake of it. And again, no surprises here. If anyone's going to make an update in Salesforce, again, that'll kind of trickle into the other two systems. So you can see how you can build out very sophisticated processes here and update multiple systems in near real time using those webhook capabilities. So if the systems that you're working with utilize webhooks or have webhooks available, you can leverage FME Flow automations to keep all of these systems synchronized and have the data up to date. So again, that can kind of support down the line processes, whether you have a workspace app that is dependent on some of these systems, that would allow your field workers to, say, download files based on the latest information, because again, you'd be synchronizing across all information or all data sets. So whatever sub-processes are executed against those data sets are now refreshed and up to date. So we'll take a look at a demo of this, and we're going to use the cartograph example here. So this demo shows a field maps survey essentially being submitted here. So we're going to drop a point. I believe we're in the Denver area at this point, and we're checking out street signs. So we will drop a point for where that street sign is actually located. We'll enter in the code or the asset ID for that essentially. Bear with me while I type this in here. And again, this is just a recording. We'll select the types of the remaining fields essentially, and we'll submit that request. And now as soon as we've hit that submit button, the webhook has been triggered from field maps to FME Flow. So FME Flow at this point has received a webhook from the Esri system essentially. And we can go ahead and look at the backend where again, this is written to an ArcGIS Online feature service. So we'll take a look at that. Switch tabs here, and we can go to the automation. And currently we have received one message. So this was from my initial testing. If I refresh the page here, we'll see that the count on that connection updates to 2. So that means we have now received that new submission from the server, or from field maps rather. We can also inspect that in the automations log, because auditing all these processes is something that is important to us. So we can keep a record of every message that we are receiving or every webhook that we're receiving from these systems. We can get that ID there. That's just a custom log feature that we're using. And then we can switch into the cartograph web UI. We can actually look for that asset because we have the asset ID, and any down the line processes will benefit from that as well. Okay, and then we'll wrap up before passing it off to Stuart with just one more customer case for this. So this is exactly what the city of Naperville is doing with automating their time-consuming processes for their electrical public works, as well as finance and water departments. So they receive, and they have a live customer example for this, so you can actually go to their website and see kind of how this works in action. This their website, I believe, allows you to submit, I think it is for tree inspections. That's what one of their public examples for. And they've used this to automate over 3,000 service requests and work orders, essentially saving tons of manual effort and hours and hours of creating these service requests by one-off requests instead of having this automation running. So obviously this automation is a huge time saver. It allows them, again, to increase their data quality, because obviously they're getting the same consistent result being submitted just with the the asset relevant data unique to that submission essentially. So yeah, this is the other one worth noting here is that this is 3 staff essentially with specialized coding skills were free to focus on other areas, so to add value to the other areas of the organization at this point. So they were able to use FME not to replace their jobs by any means, but instead to free them up to do other value-added tasks. So whenever you're looking at an automation platform like FME, don't look at it in the perspective of we need to replace jobs. You're actually freeing up for other value-added aspects of the organization. So that's a great way to free up your short-staffed organization, if that is the case, and allow them to focus on other areas that will improve operations in your organization. So at this point, I will hand things over to Stuart, and I can stop sharing my screen now.
Great, thanks, Chris. Okay, fantastic. So we're going to talk now about high-velocity data streams. So how does this vary from what Chris was talking about? Obviously, Chris was talking about working with real-time streams, and so the focus of this section is important for you for 2 reasons. If the latency of automations is too high, so when you run an automation, it takes a few seconds to run. So if you want even more kind of near real-time processing, then this would be interesting to you. The other part of it is if the velocity of data that you're working with is so high that automations can't keep up, then this solution offers much higher potential to process larger volumes of data. So, tens of thousands of messages over, say, a 10-second period is completely attainable with this pattern. So let's start with the data. There's kind of 2 groups of data when we're talking about doing data integration. We've got bounded data and unbounded data. So far we've talked about working with bounded data. So this is data that's finite. it has a discrete beginning and end. So typically when you run an ETL process, you load a block of data into memory, you work with that data, you loaded it from disk, and then you write the data out somewhere and the process ends. So that's good because you're loading that data in a block, you can work with that data as one group and do processing on it, filtering, whatever you want to do. But with unbounded data, it's infinite. You have no beginning or end. And this is the type of data that you associate with stream processing. And FME handles both, but it is a different pattern, and that's what we'll explore in this section. So let's talk about some use cases for working with these kind of high volume real-time streams. There's a variety here. Business applications is one we've seen. So this is all about driving kind of real-time business intelligence. So it might be high volumes of data coming in from on customer orders into an e-commerce platform, airline reservations, bank transactions. So I'm talking here tens of thousands of messages over 10-second period, very, very high data volumes. The next would be digital information. So we've done less with this. That would be kind of capturing the dynamics of online engagement and system health. So click streams where people click on a website, processing huge volumes of log data to glean kind of system patterns to identify if there's any health concerns, and also even processing vast volumes of email. The third scenario is the one that we've done the most work with here. And this is kind of the easiest to relate to, I think. And this is capturing data from the vast and growing network of connected devices. So IoT, and here we're translating this real-time data from sensors connected to the physical world into actionable intelligence. So some things we've seen here, obviously smart city infrastructure is generating now vast volumes of data. We've seen, what have we seen? We've seen autonomous mines now that are being built where all of the machinery is driven by sensors and they need to ingest all of that data to make sense of it. We've seen vast volumes of data from rolling stock on trains, GPS data, sensor data on every single carriage, and every single locomotive in North America. So it's this kind of pattern where the volume of data is extremely high. And the FME platform has extremely good coverage of kind of all the core IoT and messaging protocols. So we're not connecting here directly to the hardware. Often when the hardware is connecting data, it sends that data back into the infrastructure and it puts the data in something like a Kafka queue, a RabbitMQ queue, or you could even put it into via AWS IoT Core into something like SQS as well. So basically the message is here. We have the low-level protocols like TCP/IP, WebSocket, but we also have very, very good coverage of all of the kind of messaging protocols that you're going to need to connect to as well. So a simple streaming pattern would be you build an FME workspace that, say, connects to a Kafka endpoint, and you can run that Kafka connector in two modes. One is in batch mode, where you say, I'm going to run this workspace and I'm going to pull 1,000 features in for processing. But there's another mode on all of those transformers that you saw on the previous page, which is stream mode. And when you run the transformer in this stream mode, it's basically connected to that Kafka queue and it's listening forever. It will just keep listening to that Kafka queue. And as soon as a message comes in, FME will pull that message and process it instantly. So we're not waiting here for a batch process to pull the message. FME is essentially listening to these message brokers and pulling the messages out of the queue in the instant that they arrive. So extremely low latency compared to, say, working with automations, which is even there, to be honest, that's really good latency. This is just up an extra level. So filtering by attribute is one pattern. So this would be, you have a raw unbounded stream, say GPS location of, let's say, some city vehicles, and maybe you're filtering based on a vehicle type. and then you're writing that out to like a data lake or something like that. So the critical thing here is you're running the workspace constantly. So the workspace is never ending. So what that means is it's hard to do group by processing. So you need to figure out ways that you can group the data to do processing. So rather than having the kind of luxury of a disk and reading data in batch, you're doing in-memory processing, basically. That's what it's called. So there's various patterns we can look at here, but one of them is you can actually chop the data up by time to do the processing. It's called windowing, and that's one way to segment that unbounded stream so you can do processing on it. And we support windowing as well on the platform. So this is the product component of FME Flow that basically takes this stream workflow that you build within FME Form. And the thing is in Form is if you're running this workflow forever, if it stops or if you turn your computer off, then obviously it's going to stop processing that data. So you can publish these stream workflows up to FME Flow. And much like other areas of FME Flow, in doing this, you can scale the number of engines. You have fault tolerance. So if something does go wrong with a connection, it will be automatically restarted. You have log files that you can look into. So it's basically taking these workflows and taking them to the enterprise so you can guarantee that they're going to run basically indefinitely. So yeah, now I'm going to pass back over to Don, and he's going to talk about an exciting new feature that's coming up in the platform.
Okay, thanks guys. That's great. Wow. Really, really great demos showing just the breadth and depth of support for Zero-ETL that comes with FME. So last but not least, we promised we're going to show you what's coming soon. And this is really, really exciting. So data virtualization, being able to create open API compliant APIs on top of any and all FME data types, systems, services, data, whatever. So this is like real-time data, so you can deliver data access via an API. So when you think about FME Flow apps delivering data to users, this is like going to deliver this real-time data to applications. So you'll be able to do gets, puts, posts, deletes, every type of REST API operation on top of all the data that FME supports. So you can think about this as, effectively make any data service, any data store, even like CSV files, cloud native. So some of the value, agility, of course, you're going to be able to build a unified application from all your underlying systems, hiding all of the stuff that's going on underneath from the API. The application is a really simple API in which to build applications. Cost savings, you're going to simplify your infrastructure because the systems built are not even going to have to know about what's underneath. And this is going to allow you to build applications faster than ever before. So you're going to be able to improve your decision making. Of course, it's going to have data security and compliance. So now when IT builds one of these, when one of these APIs is built, you don't have to worry that anybody using that API is going to get access to data through which they're not authorized, because everything's going to have to be authorized. So it doesn't matter what application is using that API, they're going to have to authenticate. And so only users who have access to data are going to get it. So that is so key in today's environment. Improved productivity, of course. Once an API is built, IT is going to just be able to go and use its resources on other things because now people will be able to build their own business applications directly on top of that API. So here's just a quick look. You can see at the top there, we have an API, and underneath we have a data virtualization layer that provides security, caching, monitor, everything you would expect from a nice REST API. Underneath, of course, anything that FME connects to. So that is super, super exciting. And here's some beta screenshots in FME Flow 2024.x. Whenever it's ready, we're going to ship it. And you can just see, you get some ideas of what this is going to look like. Endpoint schema, security, API details, all sorts of things. Everything you need is going to be defined there. And Inform Workbench, data virtualization is a full-time citizen. And so right when you connect, get started, if you're going to be working with data virtualization, you see it right on the main screen, and you'll connect to a data virtualization API. And from that API, you'll be able to pick endpoints, and then the workspaces will be there. You're not going to have to hunt through FME Flow, finding the workspace that corresponds to your API. It's going to be built right into Form and Flows right across the entire platform. So we're super excited about that. So there you go. In conclusion, we showed you a lot today about how FME and Safe Software supports Zero-ETL, a little bit about us. We've been doing this over 30 years now. We have 25,000 organizations that use us, 200,000 users. So a well-established tool and technology, very, very healthy company from which you can use your Zero-ETL solutions or enterprise integration to feel comfortable. Some resources, Enterprise for Dummies book, written in a dummies language, a lot of fun. If you don't know about spatial data ETL, that's a really, really easy read. Our Academy, maybe you're a new user or just starting out or an existing user and you want to learn more about the Academy. These are nice little bite-sized modules where you can learn at your own speed and what you're interested in. Our knowledge base is so rich on how-to articles and demos for you to get started or learn how to do things. Webinars, find out what's coming. Also, there's an incredible library of all the things that we've done. So, for example, if you want to know how does FME work with Gen AI, how can I leverage Gen AI either for authoring or within my workflows? Hey, we've had a number of webinars on that. We have more coming up. Very fast-moving space. And so that's super exciting there too. So you'll find lots of great information. Elizabeth just does an amazing job. Next steps. Contact us. We love to talk to people about data challenges, enterprise integration. We pride ourselves not just in our product, but also in our service. We talk about a restaurant model, and we view when you engage us, you're getting both. You're getting the product and the service. We don't view service as a thing you should pay for. Just like when you go to a fancy restaurant, you don't have to pay for the service. It all comes together. And so talk to us. You want to get started, maybe you've been using FME for a while, and you want to or you're brand new, the accelerator is perfect for you. 90 minutes, by the time you leave, you'll have a great idea of how FME works, what it can do for you, hands-on, through a browser for both Form and Flow. You do not have to install anything. You do not have to engage IT. You can just simply log on. We set it all up through the browser. You can have a great hour and a half, and you too will be excited about FME.
Excellent. All right. I will go ahead and share my screen now and wrap us up here with our community badge code. Thanks, Dawn. Okay, so if you are a member of our FME community, you can claim your badge for today. I've just dropped it in the chat as well as a thank you for joining us. And if you are not yet a part of the FME community, it's a great place to network with other users alike. We actually have a brand new community interface and features as well, so check it out. All right, and with that, we do have some time remaining here for Q&A, so I'll invite our presenters to come back on with their webcams, and we can take a look at the questions panel here. I know we've got quite a few that have popped in, and thank you, Evie, as well, for helping out there on the back end.
Thanks, Elizabeth. Yeah. Just reading this through.
Yeah.
Yeah, it looks like Evie knocked out almost all of them that have come through already. So that's awesome. Thanks, Evie.
What the one here is maybe applicable, Chris. What are the currently available data validation URLs and associated CAD layer naming standards?
Right, so that would be a good one for either your own organization will have their own standards that you'd like to adhere to, or if you're in a municipal setting, your municipality may have their own set of standards that they'll have guidelines essentially for. So I know locally we have, I believe they're called M&P. Apologies if I'm getting that name wrong, but they essentially publish their municipal guidelines for receiving CAD files for development, and that's one example that is used, I believe, in BC and Alberta. So they will essentially provide a PDF with all of the specifications for the CAD files, and someone can look at that specification and leverage that logic in an FME workflow. So you could look for the same either in your organization or your own local government, depending on what you're trying to do there. So yeah, good question.
We had a few questions around data virtualization. So love the data virtualization. Will it be able to work as an API gateway? That's a great question. So I can answer that one. I think eventually, so an API gateway is kind of comprehensive in terms of things it offers, like throttling, IP filtering, things like that. What data virtualization is going to do out of the gate, which is really, really powerful, is it's the ability to essentially put an API on top of your internal data systems. So if you have multiple databases, multiple formats even, it could be file formats, and you want to create an API that you can put out there either internally within your organization or publicly, that's going to make this really, really easy to do, kind of democratizing these internal systems and making them available through an API interface. The focus initially out of the gate is less on the kind of throttling and things like that. If you want to do those more advanced kind of API gateway things, then you would need to do that in a layer above in your infrastructure. Yeah, if that answers the question. But I mean, who knows where we'll end up eventually with it. And the ETA for data virtualization, as Don alluded to in that presentation, we are hoping to target it at some point in 2024, probably later in the year. Yeah, .1, .2, we're not sure, but yeah, I think more time-based, it will be later in the year, towards kind of the end of the year.
Awesome. And then I think we have one more to answer here, and it is what type of isolation you offer between different integration flows. And I believe this would be related more to how you're creating or authoring those workspaces. So again, coming back to those automations, you have the ability to string together multiple workspaces. So if you want to isolate a specific component of your pipeline, essentially, you can do that as a separate workspace. So I believe that's what it's alluding to there. Yeah, automations aren't limited by the number of workspaces that you can have in them. It could be an automation running a single workspace that does integration across multiple systems, or it could be multiple workspaces all doing their own individual integrations, essentially running in a sequence or in parallel. So you can isolate your workflow depending on how your process is preferred to be broken down. And again, if you want to leave more of a paper trail as individual job logs rather than one very big mammoth job, you have the ability to do it that way. Stuart, anything to add to that one, or?
No, I think that's a good overview. Yeah.
Awesome. And yeah, I think that is the last of them.
Yeah. No, it's good. I mean, I'm really excited about the data virtualization. I think it's one of the best things we're going to release for many years. It's a big cross-team project internally, because obviously we need to get form. We need to make it as easy as possible to generate and work with all the endpoints in form. So if you have an API with hundreds of endpoints in it, we need it to be really simple for it to kind of drop those endpoints in form so you can start connecting everything. So it is a lot of work, but I think the end result is going to be really, really great for you. You're going to be able to create these APIs just, would have taken you days, weeks before. You're going to be able to do this in hours. So personally, I'm super excited about this feature that's coming.
Awesome. All right, so as we wrap up here, big thank you to Chris and Stuart and Don for presenting the material today and putting it together for us. Really appreciate your time, and to our whole audience as well for joining us here today. Thank you so much. We hope you all have a great rest of your day. If you do have a moment to fill out a webinar survey, we really appreciate any feedback. I will drop that link in the chat again here. And yeah, I hope you all have a great rest of your day, and bye for now.
Thanks, everyone.